So in this video, I'm going to be creating a PHP version of a BrainFuck compiler. We'll get into that in a little bit, but right now what I'm doing is I'm setting up my initial environment. I like to do this from the command line because I find it's easier. I can copy things back and forth a lot quicker than I can in an IDE, and I can set up the basic directory structure and file structure. So as you can see right there, the first step that I take is I write a failing unit test for the application, the main class of the application. So now that I have a failing unit test, it's time to set up Netbeans to run the unit test for me and then actually make the unit test pass. So as you can see here, I've got a passing unit test. So now I'm going to make a second unit test that's going to obviously fail. In this case, I'm actually going to make the unit test do something functional for what I want, basically giving it a data provider because I know I'm going to be testing multiple programs in the future. So I'm giving it a very simple program right now based off of the spec for BrainFuck, which as you can see in the lower right hand corner, I have the Wikipedia page open for. So now that I have a failing test, I can actually add and hard code in to make it pass. So right now I'm actually going to commit that because that's the first working quote-unquote version that I have. So now I added a second test case for an actual program. So now that I have an actual test failure, I'm able to come in and write some actual code to work on it. So in here I'm just basically doing an initial first draft, not really thinking much about what I'm writing, just solving the problem. And the reason I say that is, that's the way I like to write code. I write and solve the initial problem first without thinking too heavily on design. I think of design of the public API first, but then in terms of the actual execution, I just let it run. So now, as you can see here, I'm pretty much filling out the basic operations, and there I have passing unit tests. So now I'm going to add another test case to test a little bit other functionality. And again, I have a failing case, so I have to go in and make it pass. One note here, it looks like I might be doing test-driven development, and in a way I am in the beginning, but I'm not going to be using test-driven development for long. Mainly because to get the initial scaffold up, I want a lot of tests. But once the scaffold in the application is running, to refactor a lot of tests, I find is very, very, very difficult. So instead, I don't write deep tests at first, or at least in this type of a problem. I write the basic functionality tests on the public API, I get it to work, and then I refactor. So you can see right now I'm starting to refactor a little bit. I've got the basic functionality there, so I'm going to commit that again to Git. And you can actually, I'm going to post on the video little links for each one of these commits so you can actually see the state of the code base on GitHub at each one of these states. So now I'm going to start breaking things out into multiple classes. So I need to actually adjust my bootstrap to be an autoloader. Very simple autoloader. Technically it probably is PSR 0 compliant, I don't know. I didn't really think of it. All I care about is that it works for my use cases. So now I'm creating an interface for an operation. So before I had everything in a big switch statement, now I'm going to break those out into separate classes. So as you can see there, what just happened is I was treating the memory and the input data fields as arrays, but then what that basically led to was that I would need to pass a lot of stuff by reference. So rather than pass things by reference, I'm going to create a separate memory and input class or object, which is going to abstract away that reference. So this is actually an interesting point here. I was originally going to have the move function here into two separate methods. And then the first one was called advance, but I couldn't really think of a good name for the move back to move it left. So rather than call it something odd, and you can see in the lower right corner I actually have a thesaurus up, I decided just to make it a single method that takes a direction. So here I'm starting to create my basic operators. The first one I'm naming plus, which basically is just going to increment the memory. And it's, again, really simple, a single line, not a lot going on there. So now I can start to refactor the language class, that run method, and really start extracting that working functionality out into multiple classes. So initially, all my logic was in the language class, but as we go on and go further here, you're going to notice less and less functionality is going to be in there. So the reason that these tests mostly fail down here at this point is I've stripped out a lot of that working code because I'm abstracting it away. So now I'm just basically creating the different operators. And the way I have it initially, the initial thought that I had around here was that the output would then be an array that the opcodes would return, or the operators would return. So every time we execute an operator, we simply return whatever we're going to output. And if it's an empty array, then that's no output. If there's items in that array, then we would just array merge that together. Initially it worked quite well, but it started to lead to some severe duplication later on, and we'll get to that when I refactor that away. But it was just a spur-of-the-moment design decision, and you'll see that the way this is structured and the way I'm writing this application, those design decisions don't really mean much in the long term. Because we're not writing unit tests for each one of these little classes as we go along, refactoring them to clean them up makes life a lot easier, because we're not fighting our tests. We have tests on that outer API, which if you notice now all pass, but we're not really overly concerned about the inner APIs of those classes. So one interesting thing to think about in that case is that, so there's a common knowledge, or I don't want to say knowledge, train of thought that you should not test private methods, and you should not directly test public protected methods either. You should only test your public API. Well, in the case of something like this, one could make the argument that the language class, that outermost class, is our public API. And all of the rest of these classes, all the different op classes, the interface, are all protected. So we really aren't concerned with the implementation details of them as much as we are with the functionality and that end behavior. Now, that's not to say once we finish all of this, we shouldn't write unit tests for every single one of those classes. But as we're building out this library and this functionality, I wouldn't be overly concerned by it. So right now, I'm basically I put in the last unit test to make it a full BrainFuck compiler. So at this moment, at about 8.5 minutes into this video, we're 100% operational. So what I'm doing now is I'm starting my refactor. I got rid of that huge switch statement, and I've actually extracted out a lot of those operators. And now I've come to the conclusion that, you know what, I want to extract out the entire parsing operation out of that language class. So really it's just copy and paste, but it's setting the stage to make things a lot more efficient and a lot easier later. So up here is a good trick that I like in the constructor up here. Instead of using raw dependency injection or requiring a framework, I'm using what I call lazy dependency injection, which basically means you type in against your dependency, but you set it to null. And then in the constructor, if it is null, then you can hard code create your dependency. So this allows the creators of your objects to inject their own dependencies, but it also makes life easy if they don't need to. So it's a decent trade-off between them. So right now here I've realized that the array returning for the output really isn't tenable. So what I've gone ahead and done is I've refactored the input class into an IO class, input output, and now I'm going through each one of my operators and are refactoring it. And one of the beautiful things is, look at the loop. Look how simple the loop becomes. 2 methods of 3 lines each. This is where I really like the refactoring and the refactorability of code, is that you can greatly simplify things and make code that's so simple and so obvious very easily. So here I'm starting to go back in and edit the parser a little bit, figuring out what how I can make things a little bit easier, a little bit quicker. We're still using arrays at this point, but I switched to using a string buffer as opposed to an array buffer, which made life a little bit easier. And one of the things that led me to was realizing that I was missing a test case for a certain type of syntax error. So now I'm going through and I'm actually extracting out some common functionality, making it more efficient because we're only creating the objects once. And here I just extracted out a function called getOp. So while we're parsing it, we go line by line. Choosing which operators actually return is now a completely separate responsibility. But one of the problems that results in is sometimes we don't have an operator to return. So I just added in a noop class, which I'm not entirely at this point happy with, but I need it to get it to work. So right here, I'm going to refactor that while loop to make parsing of those if conditional brackets, square brackets, easier. So what I did is I initially wrote a regex, and then I'm going over to the command line and using the command line to fine-tune the behavior of the regex. I'm using it's a recursive subpattern, so it actually will match an entire brace. So once I've got the regex to the point of the command line where I'm happy with its behavior, I'm able to actually then inject that into code and then start refactoring away and start plugging it in. So if you notice, that's a fairly significant regex. Well, once I'm 100% confident that it's going to work, I'm going to actually go back and document exactly what it's doing and how it's doing it. And again, here I've got things pretty much working, but I'm having a little bit of a struggle with a test. And I finally got it. It was an off by 1 error. So I was able to actually extract that out again. I've got the loop in the second area. So this is an interesting test that I chose from Wikipedia. It's basically rote 13. And the reason I chose this one is because it uses nested loops. So this will really test out that regex to make sure that it works. And sure enough, it does work. So now, as promised, here I am documenting that regex. Because it's not trivially readable, I highly recommend that any refactoring to a regex be heavily documented. So I'm going ahead and commit away. So we commit it again. Now I've noticed that there's some duplication in those operators. So I'm actually going to start going in and refactoring them away. The first one is combining move left and move right into a single class. And then I'll do the same thing with plus and minus and refactor them into a change class. So pretty straightforward. All the tests still pass, and I'm constantly running those tests. So now I've realized that, you know what, that no-op, time for me to get rid of that. So I'm going through here and actually trying to figure out how to get rid of it best. So I've basically gotten rid of it already. Okay, so now if we go back and take a look at all the files that we have now, take a look. There's almost no conditionals. The tests are pretty straightforward. The interfaces and the code is all very straightforward. At most, 1 to maybe 5 or 10 lines per method. No conditionals. yeah, really straightforward, easy to read. I'm happy with this code. It took me roughly 2.5 hours to get to this point, but I can't really see that much better that we can do. The one final thing I have left to do is actually delete that no-op class that we're not using anymore. So there we have it. In, like I said, just about 2.5 hours, from complete scratch to a working solution to a very clean refactored solution. I'm happy with that. Not bad at all. So let's take a look at our actual metrics. So I'm going to run a code coverage report here, textual code coverage. And if you look, even though I'm only testing the public API, we have 100% code coverage on the entire application. So every single line, every single if branch is tested. And that's the way I like to do things. Basically, by going through and working at it and refactoring appropriately, you can get those coverage without sitting down and worrying about it. So if you look at these PHP Loc metrics, you can see some really interesting things. Our average cyclomatic complexity per method is almost nothing. The number of lines of code is low. The number of lines per method are very, very low. So I'm finally going to stop, commit the code, and we're done. So thank you for listening.